Okay, we'll wind this up now. There's only a small bit to do, but it does involve a bit more kind of 3D theory. So we'll put this back to 2D wireframe, and then we want to bring on the partitions layer. So we'll turn the partitions layer on, and then we'll freeze. Actually, turn it on and make it current. Make that the current layer, and then we'll freeze off the windows and their framing. Okay, so you should just be left with this letter T for the shape of the partitions. Okay, I'll zoom in on this. And what we'll do, I'll demonstrate the kind of the slick kind of professional way of 3D facing this, and I'll show you the kind of shortcutted version as well that doesn't always give you good results in the end. So the way we'll do it is kind of the optimum method that will give you the best kind of 3D shapes. So firstly, we'll copy this up to two different heights: the height of a doorway, and then up to the height of the building. Okay, now this building is exactly 3 meters high. Okay, so instead of using the heights from here, we'll just type in numbers this time for the heights. So it's copy, so it's CP, return, grab the white objects that are there, and return. Base point could be anywhere. Put ortho on for this because we want the copies to go directly upwards. So pick a base point, set the direction. Okay, so we've got +Z showing at the cursor, and we'll say that the door height is 2200, a bit more generous than a standard door, and then to the top of the walls would be 3000. Then press enter to finish. Okay, now we need to identify another point across the doorways. Okay, so we're going to need a line from endpoint to perpendicular. Then we can copy that up to this point as well. So it's line, L, return, fluff that. So line, we need to change the object snaps because we had it just set on midpoint previously. So we'll swap this back over from midpoint back onto endpoint, and so it's line from endpoint, and I want to go perpendicular to here, so shift and right click your mouse and perpendicular. Okay, press enter, and then copy that line up to this position, CP, return, pick the line and return, base point, destination point. Okay, so we've got our 3D frame, our wireframe that we can now start applying surfaces to, and effectively this is 3 rooms, one here with the doorway, and then another room's on this side. Okay, so we'll start inside the doorway, inside the room with the door on it. So remember, use shift and middle mouse to reposition. And then we want a 3D face, so 3F, return, and we'll start by lining the door. So if I start at this point, so endpoint, 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 endpoint. Okay, you could carry on, but we'll just do this in 2 bits. Okay, so return to finish, return to bring back the command. We can switch ortho off now, we won't need it for a while. And then we want a 3D face at the top of the door here. So endpoint, 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 endpoint. Return to finish. Okay, so we've shaded, we've solidified the door surround. Okay, and things are going to be a bit different now. So this shape and this one are no longer needed. They've done their work. We can get rid of those. It makes things look a bit easier. And what we're going to do now is 3D face these in a slightly different way. We'll be using generally kind of trapezium type shapes. I've fluffed left again. We actually need a third line here. We need another line. So a line from endpoint perpendicular to here. Okay, so it's 3 of those lines. Okay, so we'll work on this side of the wall first. So it's 3F, return, point 1, 2, 3, 4. Okay, return twice, so you can use the command again. Point 1, 2, 3, 4. Okay, and the reason for doing these types of shapes is so that the surfaces share the vertices. So at this point here, there's 4 3D faces sharing that vertex. Okay, where these 2 faces meet, they share a corner as well. You notice that they're always, when they kind of meet up with another 3D face, they're sharing corners. And this, what happens here is that it will weld these surfaces together better. Okay, so we'll look at this side now. This one's a bit trickier. So 3F, return, pick 1, 2, 3, 4. Okay, so it's still doing this sharing of the vertex. Okay, and the next one's probably the most awkward one. It's kind of underneath the door and then down and along. So 3F, return, under the door, 2 points there, and then 3 and 4 right over to here. Okay, so it's wrapping around underneath the door head there, but still sharing the vertices with the other 3D faces. Okay, if we do shaded with edges, we would see those edges. Okay, shaded normally, we wouldn't see the edges. Now if we were taking this through to a visualization software, it doesn't matter if we left these visible. But if we were going to do something in AutoCAD, if we're going to generate maybe a hidden line drawing, then these would be quite unsightly. Okay, but we can get rid of them. You can use what's called the edge command, EDGE, return, and you just select the diagonals that you want to get rid of. Okay, you click on it and press enter to remove it. Bring back the command, click on the line, enter, and it hides them. But they're still there, they've not been deleted, they've just been made invisible. Okay, if you wanted to see them, you have to use a setting change in the software. It's called SPL Frame. Okay, at the moment it's set to 0. If we change it to 1, it will force the visibility of those edges. Okay, if I type regenerate, it shows them again. But they've still been tagged as invisible. So if we turn SPL Frame back off, SPL Frame, put it back to 0, regen, they disappear again. Okay, so the 3D information is still there, it's just hidden. Okay, we'll move to the outer wall now. We'll deal with this wall. There's some lines in here that we don't need anymore. So remember the SSX? That would help us pick these 3 lines and get rid of them. SSX, return, pick the line and return. 3 found, that's correct. And then use the erase command with the P for previous setting. So E, return, P, return, return again to finish. It's very quick. It's a good way of weeding things out. So it's 3D face again, so it's 3F, return, and this time the surface is going to be bigger. It's still going to be a trapezium type shape, so pick 1, 2, 3, 4, return, return, 1, 2, 3, 4, return, return, 1, 2, 3, 4. return to finish. Okay, you shade it, make sure it's doing what you want. Okay, and then we can hide these edges. So it's edge, return, pick, pick, return. Okay, we'd want to see that line, so we wouldn't hide that one. Okay, and then the final surfaces are going on the inside here. These are just simple rectangles. Pick 1, 2, 3, 4, return twice, 1, 2, 3, 4, return to finish. We could pick out these polylines. Remember SSX again? SSX, return, select an object. It's looking for polylines on layer 3D partition. Press enter to finish. It's found 4. E return, P return twice. That clears those away. Okay, so we did that in the kind of optimum method. I'm just going to insert another block to show you the difference. So I've got alternative 3D facing here. Let's let it come in at 0, 0. Oh no, I'll control it. Okay, so I'll just place this nearby just so you can see the difference. Okay, so this has been 3D faced, but in a much cruder way, just going straight up and down at each position. Okay, and the problem here, if we compare these two surfaces, they're touching each other, they're joining up properly at this vertex, but they're not joining up properly at this one. Okay, because they're not sharing this vertex. He's using it, this one isn't. So what happens is this connection between the two 3D faces might end up showing up as a crack on the surface. Okay, and it could also actually let light through. So in a scene with strong lighting, you might actually see a strip of light leaking through between these two surfaces, and that would spoil your visualization. And you might have to backtrack a long way to come back and sort out this part of the model. That would be very awkward. Okay, so that's the kind of theory behind that. It's the welding of the objects together that's really important. Okay, the final thing to do here is a door. We've got a door to put in here, so we'll need to see the shapes here. So I've got a door frame layer which I'll switch on and make current. Okay, so we've got the objects on the ground here, and we're going to draw this in a slightly kind of more efficient way. Previously, when we made the window frames, we just had a box, extruded it, and then made our own box to go across the top. Okay, this time what we'll do is we'll set the coordinate system to be looking at this side of the surface, and we'll polyline the shape of the door. So we'd worked on the right hand UCS earlier. This time, if we're looking at this side, this will be the left UCS. So you make sure that the object changes, and then polyline, so PL, return, we draw around the edge of the doorway. Okay, we'll offset that in the way by the thickness of the door frame as it's drawn. So it's O, return, pick the size for the offset from the drawing, click on this line, go inwards and pick again. Okay, let's erase these two rectangles, let's get rid of these. Okay, we now need to close this shape. It's two concentric lines at the moment. That's no use for creating the frame. So if I draw a polyline across the bottom and then fill it to join these together. So F, return, pick, pick, return, pick, pick. Okay, now that, press escape, that has only joined it on one side. We need to close the shape, and the best way to do that is using the pedit command. So it's PE, return, pick the yellow shape, and then we want to use the close option, so it's C, return. Return to finish. Okay, you've now got an extrudable shape, and you know, if the door frame was a tricky profile or whatever, this is a better way of doing it. So extrude, pick the shape and return, and take the extrusion to the depth of the wall. So we've got a nice clean door frame inside the door opening. Okay, and then the door itself, we've got the door leaf layer. If we turn that layer on, make it current, back to 2D wireframe, and I've got the door leaf drawn here, but we'll delete that one and we'll just draw the door as if it was closed. So it would be a rectangle, so REC, return. Oh, tell a lie. Yeah, so you could draw your door leaf vertically, or we could draw it back on plan. So put the coordinate system back to the world. You could also do UCS and return twice. Okay, and then rec, return. Going from endpoint here, we want to go to midpoint. So shift and right click your mouse, midpoint, and select. And then we can extrude that and pick a point on the underside of the door frame. Okay, if we shade that, we've got a door in there, and it looks like the door's closed. But depending on the amount of time you've got and the level of detail you need, you know, you could work much more on that door and put in vision panels, door handles, kick plates, whatever's needed for the door. Now, if this was a door that was going to be used in different widths, then I might have done that as a 3D faced object instead of a solid. Then I could pull and push that to suit different door openings. Okay, so that is the final part of the model. Okay, if we want to unlock the 2D layers, we're finished with those now. So -LA, return. We want to unlock, so it's U, return, and we'll just unlock all the layers, star, return twice. We can now pick these objects and delete them. And we want to bring back on all the layers now. Remember, they were frozen. Most of them were frozen. Some of them might be switched off as well. So let's just see what we've got. No, they're all just frozen. Okay, so it's -LA, return, Thor, so it's T, return, star, return twice. Okay, if I shade that, we've got our elegant little Barcelona Pavilion model, and we can get rid of any layers we're not using anymore, so the 2D layers could be purged from the drawing. So I'm going to do a save as, and this is the Pavilion complete, so I'll just give it a second name so I don't save over the one I've already done. Okay, and then I'm going to purge that, PURGE. It looks through the drawing, looks for anything that's been brought in that's now no longer needed. If it's not visible, then it's at risk of being purged. So I'm quite happy to let everything go. So put a tick in purge nested items, so any blocks that might be in there, it will take away the layers for those as well. So purge all, close. If we look at the layers list now, there should be no 2D layers anymore. Only the stuff we can see is visible. Okay, so that's the end of that 3D modelling. Remember, this is in millimeters. It might be necessary to scale this down to take it through to 3D Studio. Tends to work better in meters. So we will do that in the next video. Okay, thanks for watching.